cool stack which I'm going to discuss with you. During the break, somebody asked me like, hey, what are the different recommendations which are available? And there are a lot of tools which are there, and you have to choose which tool really works. Thank you. How about it now? Hello? Yeah. Okay, good. Thanks. So there are a lot of tools which are available for us, and out of these tools, this Mac stack, it came around last year, and it has in our company also we are evaluating to start using that. We are already using from this stack Spark, Mesos, and Cassandra and Kafka. So these are the 4 things which we are currently using in our system. So we'll discuss about these technologies as part of our discussions today. So let's get started. So it's a packed agenda, as you can see here. Now covering this in 1 hour, and you want to make sure you get a good understanding of what it is. That's my main goal here. Okay. So if you have any questions, just raise your hand. I'm perfectly fine. We can slow down as whatever way you want to do that. So we'll start with what's the stack overview is, and look at the big data characteristics and why that is taking us towards this direction. And then we'll look at Cassandra, Spark, Kafka, Akka, and at the last, Mesos. Okay? Does that sound like a good plan? Okay, good. So what is Spark? Spark is for micro batch processing. That means when I want to get the data processed really fast, and you want to do parallel processing of that data, then Spark is the best way to process the data. That's what it means. Mesos is for cluster management. That means you have a cluster of Docker nodes, or you can call cluster of different services which are available to you. How to manage them really well. That's where the Mesos comes in. Akka acts as an event processing system. Let's say you're monitoring something. You're listening for a port. You're listening for user actions. When somebody tweets something, you do some action on top of it. Same thing is true. You're running some heuristics using some database table. So if there is a database table which gets updated, you want to monitor that database so that you can make sure you can run some analytics on top of it. That's what you're using Cassandra for. Kafka is for event transport layer, where when you are processing the data, before processing the data, you have to send the data to process it. Yes? What we are using before, we are using RabbitMQ. We are using ActiveMQ. But if you have a bigger load, in that case, and you want to be fault tolerant also, and you want to make sure you have partition. You can partition the nodes. In that case, Kafka is really good and process it really well. That's where the Kafka is used. So if you see this diagram, Mesos is acting as an orchestration tool. Akka is acting as a raw event sourcing. Your event is getting sourced from here. It goes to the Kafka cluster. So this is the Kafka cluster which has a broker in it, and it can do processing, send the data in the micro batches to Spark streaming, which then sends it to Cassandra. And Cassandra can have 2 ways of connecting it. So now you may ask me like, hey, why I have two different sets here? The reason I have 2 different sets here, because the first set is the read-write, where you're doing more write operations. And the second set is for analytics. So this is called near real-time analytics. What is it called? Near real-time analytics. What we have been doing since like 15 years back or 10 years back, the best way to do that is to write an ETL process. How many here have ETL process? Which runs in the background. It runs at night. In the morning, you get the data, processed and available for analytics. What we are trying to say here, by using this model, you will be able to get analytics started in 5 seconds. So in our company, we have 5 seconds limit, like, within 5 seconds, our data should be available for us to process and start using it. And I'll talk about in like a little bit detail, like what it means. But this kind of give you an idea, about different technologies, yes? Okay? So what's really happening is that big data as a characteristics, let's talk about this for a second. So now if you see this, data can be at rest or in motion or in different forms, or you have a doubt about the data. What you're really looking for here is, if you are talking about analytics, what you're looking for is, the data is terabytes of data. It's not 1 terabyte. Okay? Also, the streaming, when you're doing the streaming, it's gigabytes of data which is getting streamed. All the internet devices which we have got right now, gaming, anybody play gaming, like live gaming which are going on, heavy processing, very, very heavy processing. Temperature control, heavy processing, which takes place there, like, how the weather will move, all those things are there. And it can be of many forms and can be a doubt. So those things are available. What's our job is to get the data, right information at right time to the right person. That's the key part here. So the decision maker, which can be automatic also, can make the decisions for you. And that's where, people say that, hey, 10 years from now, there'll be more robots, doing most of the mundane work which we have got, because they will give us the feedbacks and they'll start working on top of it. So, that's pretty much coming right now. So the important part here is, if you look at this picture, here there's something called here real-time analytics, where you're analyzing the results. That means the data is not residing in one node. It's residing in hundreds of nodes. Okay? Also, data is being processed in memory. So you're not going to HDFS, like, you're not going Hadoop way, which is going to a database and then retrieving from the file system. It's all in the memory. You're always doing an insert. What are you doing? Always doing an insert. And the data is either in the columnar fashion or as a row fashion. Both are possible in this case. So that's the key part. I really like this because with analysis, you predict and then execute on the prediction on that particular record which has been given. Important thing is, you have to be 99.9% available. You have to be available all the time. That's the key part here. Which means, if I say 52 minutes, it's 5 minutes per month you're down. Very hard to achieve that. Like a lot of companies, they have problems achieving that. But technologies you can use, if you use this stack, it's possible to achieve, if you build it correctly. And response time of less than 500 milliseconds. That's another key criteria which I have got. You want to make sure that all the data is retrieved faster. How it will be retrieved faster? Because it's in Cassandra. It will be retrieved much faster for you. That's where it comes in. Somebody comes in and tells you, I want the highly available system with high consistency and partition tolerant. You go and tell your product owner, it's not possible. Why it's not possible? Because of the CAP theorem. Okay? What CAP theorem says that you can only have two, A or C. You can be available and consistent, both at the same time. You cannot, that's the key part, you cannot have all three at the same time. So if you are doing RDBMS transactions, you keep on doing the same way. No problem about it. You keep on, whatever your transaction is, you keep on doing the transaction. No problem about that particular transaction. But whenever there is a transaction done, you do raw event sourcing. You do the event sourcing on the transaction, which is here done, and send that data to be more highly available and partition tolerant. Make sense? So now the query which you used to write, which has no guarantee it will come back even in 1 minute, it is always possible to be retrieved in less than 500 milliseconds. That's the key part here. That's where we're going to use Cassandra. That's why we are using Cassandra from here. This diagram is just to show, like, we are doing the raw event sourcing. When I'm doing raw event sourcing, what I'm using here? Akka Kafka I'm streaming the data from CA to AP using Spark and sending it to Cassandra. Make sense? And why Cassandra had two nodes there, two clusters there? One cluster was for writing the data. One cluster was for reading the data. So reading the data will be really fast because it's like independent cluster. It's just a replicate of the previous one. That's the key part which is really important. Now let's go back to our diagram, back to this diagram. If you see this portion, Akka, and when I'm sending the request, the database change has taken place. You can send this request out whenever there is a user action or serverless, like AWS Lambda also is coming along, where you just have a snippet of code which is just analyzing the database table and sending it to Kafka cluster. And there you're only paying for the script, the time when you're running that particular script, and it's much faster that way also. Now, and with this, when we come to the analytics part of it, so when you are doing read-write operation, you put it in here, and then analytics is done on the other side. Okay, so let's talk about Cassandra quickly. So it's highly scalable, eventually consistent, distributed. So distributed means that it can be in many places, and key value store. That's the key part here, key value store, which is there. It's been developed by Avinash, Bigtable, and Dynamo, and then when he came to Facebook, 2009 time frame, it became popular, and Cassandra was created. You can download Cassandra independent. You don't need to use DCUS to do that. And the reason I'm talking about these technologies separately, and then I'm going to combine them later on because that'll make sense for you. Okay, using the DCUS model, you can combine all this in one place. But this is a secret sauce for Apple. They were able to scale really well. Secret sauce for Netflix, linearly scalable. Like you can put as many nodes, and read writes are pretty good. All these companies are using it. It's not like one company who's not using it right now. Netflix got 30% of internet traffic. Now, if they're successful, you probably want to use this. And it's, I think I oversold there. So, but it's a Netflix case study. I wouldn't want to spend much time here, but the whole idea here is that if a node goes down, you should still be perfectly fine. And Cassandra supports that model. How it does that? Because what it does is that whenever there is a request being sent, there is no master-slave concept in Cassandra. There is all the nodes are master nodes. So that means you can send the request to any node, it will process your request. It knows the token. It knows where it's residing. So it already knows where it's residing, and you can get the value from there, which is pretty good. Yes?
So in the original diagram, you had two Cassandra nodes, and it was getting replicated.
Yes.
In this case, when you have a cluster of many nodes, how can all of them be mastered then?
They can be mastered because Cassandra provides that support. So when you say data center, when you create a data center, within the data center you can have rack 1, rack 2, and I'll talk about that in a little bit on that one. But you can create as many as you want. There's nothing wrong.
Only, replication happens for specific blocks in different.
Yeah. So what I'm saying is that this is a cluster, data center 1. This is a data center 1. This is a data center 2. It's just showing you a network diagram right now here. But it's all like, this is one data center, this is another data center. If this fails, then it goes to this data center. And there's not only Cassandra, but the other things also here. Web server is there, and Memcached. Other things are also there as part of this. Yeah?
You said the Cassandra analytics, right? It is nothing but a Cassandra plus Spark, right?
Cassandra, yeah. You can put Spark, yeah, data stacks. You can use with data stacks. We are using data stacks because if you're using enterprise version, you might want to use that, yeah.
That's how we can do the analytics right on the board.
Yes, because you cannot do all the queries. So the question is basically, hey, these things are all indexed, saved in the database. How am I going to do the query? So that's the key part here. Yeah.
So in terms of Cassandra, right, does it have any advantages over MongoDB or Couchbase? Why specifically Cassandra? Second thing is in terms of read and write, you're saying both are Cassandra. Why can't read be from HDFS, and why not write only to Cassandra? So
Excellent point. So let's talk about this. I would not go in much more detail than, if you want highly consistent and partition tolerant, you're going to go with Mongo. You want more consistency. That's the main thing Mongo does. Provides you more consistency for your database. But actually, I have a separate talk just for which one, all the databases which are available, what multi-tenant database to use. That's tomorrow, last talk, which I'm going to talk about it. So, but we can connect after the talk more in detail on this one. Thanks for the questions. So, this is just talking about the Hystrix model, just analyzing what the data is there. When one zone goes down, you go to the another zone, and basically, your Cassandra nodes should still work. That's the Chaos Gorilla is the testing strategy, which does that. So what I want to do is that, I just want to talk about, the main key points for Cassandra, which is 10x throughput, 8 times faster, and 8 times write throughput. So you're going to say that how is it possible? Like, hey, how am I able to do this? So the reason you are able to do that is because what you're trying to do is that you have, for example, this node here. This is one node which is available for you. You can have a replication factor of 3. When you say a replication factor of 3, that means the data will reside in 3 different nodes. Okay? And then what happens is that Cassandra has a terminology for key space. A key space has a table, has a partition, has a row. That's the way it has got. This is the replication strategy is there based on what key space you are trying to define here in this case. So what it means that when you have a replication factor of 3, that means data is residing in 3 nodes, and you can also have different other strategies. For example, network strategy can be there to do different things for you. But when you are inserting the value, you can insert a value in one node. It will go to this node wherever the data should be residing. And you may say that, hey, if the request comes to this node, what happens? Because any node can be master node, yeah? So if the request comes to this node, it will insert this node and also send to other nodes. Other thing important here is the consistency level. You can say consistency level of 1, that means it will only insert here and return back. Consistency level of quorum, that means it will insert in these 2 places and return back. It will also insert here, but it will not wait for it. So it depends upon how much consistency you are really looking for. The more consistency level you have, the slower it will be to return. I mean, that's something you have to work with, so this is the insert model which is there for you to use. Now, what's really happening is that creating table-wise, create table, comments by user. So when you say comments by user, that means we are having denormalized tables. Third normal form is not a good way to do that. That's the key part here. So what's really happening is you have a primary key of user ID plus the timestamp and video ID. And with the clustering order of these two are used for the clustering order. The reason it's important to have the clustering key, and you have to make sure that you have enough size in the clustering key, is that clustering key must reside in one node. It should not be really huge. It should not be gigabytes of data. It can be of 10 megabytes is fine, but it should not be a lot of data which is there within that. So what happens when we are doing a write operation, and why is it fast? So when I'm doing a write operation from here, it goes to the memory, mem table, it also put it in the commit log. Now because I'm putting in the mem table, if there is a replication factor of 3, what's the probability that out of those 3 nodes, at least one node is still available? Pretty high. So that's where you get more consistency in terms of you still be able to be more available. So that's why they say that it's more highly available system. If something goes wrong with one node, it will still can be processed using another node. That's the key part here. When I'm reading the data, it's the same thing. It basically gets the data from different SS tables and combine them and then send it across. That's what it's trying to do here. It send across the data, so that's why it's fast, because it's already indexed. Data is already indexed. You don't have to re-index them again, because data is already stored in the format which you can just get it and then return the value. That's the key part here. So let's talk about CrossFit. CrossFit is, you heard of CrossFit, yeah? So CrossFit is a gym, but they're available in 2 different countries. So when you first create a table, you're going to create like gym name, text, city, state, country code, and primary key. This is one single table, one single clustering key. Is that a good thing? No. Because it's all everything put it into one table. So that means for our primary key is clustering key is like one gym name is there. But what can we do here? Instead of one gym name, what I can do is I can add the country code as part province and gym name as part of my clustering key. Now, because this is my clustering keys, I'll be able to get the data as from the clustering node. It makes it much easier to get the data from here. And you can put the clustering order on top of it, and it will return me in that order. That means the important thing here is that you have to ask the product owner how my data will be retrieved, and make sure your queries are made that way. Make sure you design it that way. That's the whole idea behind this. So what I want to do next is, I'll come back to that later on, but I want to go over the Spark after this, so wouldn't want to spend time there. But this is important for you to know. When you're building the data model, this is the key part here. When you're building your data model, you want to make sure that you have a conceptual model. Build your conceptual model, build the application flow, and make sure you create a conceptual logical model out of it. And that will give you performance. That's the key part which I'm trying to say. Where the queries must be really lightning fast. You want to build a query, it should be really fast. And if I give an example for Krill video, like this is an example for Krill video where you have multiple videos are there. You want to make sure that you first create the conceptual model of video has many actors, an actor appear in many videos. You just find this thing out. But you create a purpose for what purpose this table is used and build the queries based on that purpose. That means the query I'm going to create here is going to be the fastest query I can think of. That's the whole idea. You don't want this way. You don't want the in clauses. What we have? We have all the in clauses there in our SQL queries. There's no guarantee how much time it's going to take if it's a gigabytes of data. So we want something like this. So for this particular abstraction, you want to first create the ER diagram. Based on this ER diagram, you want to build application flow, where you are saying that, give me most recent videos, known ID for the recent update videos. Those will be your tables. That's the whole idea here. What I'm trying to say is that when you create the table, you come up with something like this. You say video by user, video comments by user, where you're creating that particular comment, this particular table based on this, different users. But you may say that, hey, it's duplicating data. Is that a good thing? Yes, it's a good thing for performance. That's the whole idea behind doing it this way. Okay, let's jump on to Spark. So Spark provides us a good way of connecting. So before I jump onto Spark, I just want to show you quickly. So this is the this is the query which I have. Are you guys able to see this? Probably not that clear. But I have a sample, example, so you guys can try them out like, later on, because I probably won't get time to do that. What I'm doing is, I'm going to drop the key space. That's the first thing I'm doing here, in this case. So I'm executing this command and creating that NFJS key space and basically inserting some values. It's pretty easy to add the values. for here. And you can do the same thing for users also, if there is NSGS users are there. And based on that, you can now send some of those queries. So in this case, I got, Rohit is there, Neil Ford is here. So when I add these two values, those I can now read those values out. And, and these values will be stored as a timestamp. Okay, at this timestamp, this value came in. Another transaction comes, that's a separate timestamp. So that's the easier way of finding out. And if you are retrieving the value, Cassandra will make sure it's sending the data for that same timestamp to you. That's the key part which I wanted to make sure here. Yeah. No, it's not on the fly. You have to create design for that. So the question is that is there a predefined schema in Cassandra? Yes, it does have it. Now, what do you need to do? You need to design this in a way you're using it. Okay? So the way I was talking about before that, how the product owner is saying that how you're going to retrieve the data. That's the way you need to design it. It is different from relational because it's much faster. The query will be like in split second. It will take less than 100 milliseconds to return because of the partitioning key also. Yeah, it's a denormalization. You are denormalizing the data. So what you do is, this is what we did. In our, is one of my friends' project, like what they did was they created a JSON object. So what they're doing is they're putting the whole JSON object as part of the schema itself. So that's another way people are getting around this. Like, you have a schema, you create a partitioning key. For that partitioning key, this is a JSON object. That's like a blob of all the objects which are available for you. That's one way we are tackling with the different dimensions which might be there and then querying based on it. Yes, and I'll talk about it, how we can use Spark for joins.
So my question is, if the use cases change, right?
Yeah.
But your data is already stored in some other, grouping.
Yeah.
If my use case product owner says, no, I want to change the flow.
Yeah.
How do you go about then changing it? Do we have to do some data upgrade?
Yeah, you can change the database table. That's not a problem. I mean, that's not a problem. Like you can add one more column to it. That's not a problem too. You can add more columns to it. You can delete a column, all those drop a column and things like that. You can do those things. That's not a problem. That's a great. Yeah.
So in a relational database, for Cassandra, you said we should have different tables for different use cases, right?
Yeah.
So if we create the same tables in the relational databases with the same partition key.
Yeah.
So that would be the same faster.
No, relational database, you still want third normal form there. I am not saying change that. What I am saying is only for transactional database, transactions, because you want to retrieve those transactions really fast. Relational database is still valuable. Like, for example, you have a stock. You want to make sure you still have a relational database, but you want to do analytics on top of the stocks. You don't want to get that data from relational database because it would not perform well. Because you're performing on millions of rows at the same time. So that's where Spark comes in. And like when I explain in the Spark how it's using, then you will get an understanding, exactly why we are saying. So I'm not saying not use SQL Server database or Oracle database. That has a value attached to it. But the use case there is you're sending a CRUD operation. You're sending insert into the database. But how the analytics is done, ETL process is not done after a day. It's done in 5 seconds here. So you can make better decisions. See what I'm saying? Okay. Yeah, you can have 2 different clusters, yeah. Yeah. Yeah, and then it will propagate to the other one. And it's fast. that way, because you're not relying on one cluster to read also at the same time. Those are good questions, actually. Thanks for asking these questions. All right. So that's where the Spark comes in. Joins are not possible. Hey, how am I going to use this one? It's of no use. But what really happening is, because we are using Spark and not Hadoop, it's much faster. When we are analyzing our results, we can put Spark and put the data in Cassandra. The combination is really very powerful. What it does, and it's 100 times faster than Hadoop, and 10 times less code than Hadoop. So, I mean, if you just look at this particular analysis, it's processing records, 102 terabytes, it's 2100 nodes, 206 nodes. So less number of nodes are there to process 100 terabytes, so which is pretty good in this case. So, and another thing is that because it's using Scala behind the scene, what you can do is you can create a SC context here, and basically you are saying text file. This is you're reading from a text file or from a database, doesn't matter. It's a Cassandra database, you're reading this value, and you're flat mapping it, counting the value and returning it into a file. It's really fast, I mean, to return this particular value. So why do you use Spark? Because of fastness, testability, fault tolerant, and it's an easy way to connect the data and query the data. So that's the reason we want to use Spark as a whole. So Spark has something called data frames. It's kind of like, you're getting data from Cassandra. Once you get the data from Cassandra, which is indexed, we talked about indexed data which is there. You get the data from Cassandra, you can write Spark SQL on top of it. So, and then based on that, you can query and get the results. You can also do Spark streaming, and that's what we're going to talk about, Spark streaming in case of our SMAC stack. You can do Spark streaming, where you're streaming the data to Cassandra or retrieving the data from Cassandra. So that's what you're using these two for. There are other two tools here, GraphX and MetLib, which you can use also along with this. Who's using it? I think a lot of companies are using Netflix, Comcast, you name it, like they're all using this one. So the whole concept is based on a driver. Spark context driver is there. Based on this context, you have different workers working for it. So you can have a Spark context, you have a job to do, you can send it to different workers to perform that job. What it means that when the request comes from the client, it goes through the master, and through different workers, when the request is finished, it returns back to the client asynchronously. That's the key part here. And the way you're going to download the same way, like you can download this with with Hadoop, and then you can start using it. By the way, Spark is running on top of Hadoop. So it's not like a separate element. It's just reusing the same framework which is available for them to use, but everything doing in memory. That's the main thing which you are trying to do here. And then you can start the Spark shell and start using as a REPL itself. It has a lot of commands. I mean, I don't want to go over a lot of commands here, but if you do the word count, this is just doing a word count example in this case, and returning the value. The main thing here is there is a GUI which comes in, which is a web UI, which can find out the Spark jobs which are running. Now, this is a Spark job which is running, save as a file. And this has 4 stages in it. How many stages? 4 stages in it. So each of those stages which we can use and actually analyze where I'm spending most amount of my time. This is green, and there might be some issues here. So it will tell where exactly we are spending time. So what we do is, as part of performance analysis, this tool has been given which is doing the processing in parallel. You can actually look at this graph and then find out where are the bottlenecks which you need to fix from this one. So you're waiting on some other people to perform the operations. So you get different stages. You're saying stage 1, this is stage 2, text file, you flat map it, and then come to stage 3. So there are 3 stages which are there. So this is something called DAG, directed acyclic graph. So that's what it is. So what it means is, and that's where the RDD which comes in, which is immutable, recomputable, so where you can recompute it, reuse it, and fault tolerant. So those 3 things are possible here. So what happening is directed acyclic graph which we have created, it does the transformation. How many here have used Hadoop? Okay, so you guys are pro at it, like what I'm trying to say here. But you're doing the same transformation, not much difference in the transformation perspective, and you're collecting and then reducing that particular action at the end. So what it means, if something goes wrong, what will happen? If something goes wrong, you can resend that same request back again. That's the beauty about this. So if for a particular processing, which I'm processing here, if something goes wrong here, it will go back here and recompute that same thing, which is really powerful way of doing that. And you can have different kinds of stages. We talked about the stages for you. Basically, what you're doing is you're transforming, and at the end, you're printing the records, or you're sending it to the user, or you're sending it to database. Those are the 3 things you can do. Basically, you are outputting somewhere. That's what you're trying to do here. If one executor goes down, it doesn't matter. The worker can still continue and finish the work, and it's still fault tolerant. That's the key part here. What are the different inputs it can have? It can have an input from any one of these. Cassandra can be also an input, or a memory can be an input. S3 can be an input here. So all these input can go to the workflow and work through the RDD method. And this is the Spark, SQL, so which is select from key space, and then because you're using Cassandra context. With the Cassandra context, you can run this, create the RDD based on this SQL, and it will basically get the RDD for you, which is kind of a data set. Once you get the data set, you can process on top of it. That's the main thing here. That's where it comes the streaming. When I'm saying streaming, it means that you can stream through Kafka, or Twitter feed, or or Akka. You can use any of these feeds. You can also use RabbitMQ. In one of our projects, because it's not heavy duty, we are using RabbitMQ for that. We are just sending through that particular same channel, we are sending it through. It depends upon your use case. That all depends upon that. So you send it through the streaming, which is discretely sending the records to the Spark to process it. That's the whole idea. It's discrete. Discrete means wait for few seconds, not few seconds, like 500 milliseconds, get the data and then process the data. That's the idea behind doing that. Where you have discretized streams are there. Using the Akka actor or other ones, RabbitMQ, we get the streams, and within an interval, we process this as part of the Spark and send it to Cassandra. That's the key part here. And that is really fast. That's the idea which I'm trying to say in this case. So if I want to process this record, what it's going to do is going to take 4 at a time. It's going to process RDD1, RDD2, RDD3, RDD4. It's going to process in discrete streams, batch intervals, and then it's going to process them. That's the streaming model which is there, which we need to do in this case. And you can also do filtering or transformation. You can add transformation here. That's what we are adding here, a transformation. So the streaming model is pretty much the same as the other model, where your Spark client is sending it to the master. When it gets it to the master, the worker sends it to the cache. Now this receiver will get input directly from the stream source. So you get the input from Kafka or some other broker to get the value from there. And of course, you can have different sources. We talked about it just now. And this is just one example of a queue stream, which is there. And just like that, you can have a Twitter stream also. If I have time, I know I could have spent time on the Twitter example, but I'll have it in my work, session, like, I have step-by-step what you can follow it through. So you should be able to run the Twitter example and see how it works also, along with that. Okay, so what it means that, so you can use any of these input sources, we talked about this, and that's where the Apache Kafka came in, which is kind of a publish and subscribe model. When you say publish subscribe model, it's in RabbitMQ is you send a topic and that topic get processed. It's similar to that where it's processing the record from, it was built in LinkedIn, but then Apache project, it became as Apache project as a whole. So what it's doing is, depending upon the use case, so this use case is the weather channel use case, you create a Kafka broker. This Kafka broker is sending it through a topic, temperature topic and rainfall topic, and sending it to different nodes. So you see this here, same thing, it's discrete. Discrete means it's waiting for 1 second, getting the data and then sending it across. We're waiting for 1 second and getting the data and sending it across. Make sense? So now the key part here, you may say that, hey, same thing I do in RabbitMQ. But this is more performant. What you can do is you can do partition tolerant. What happens, rainfall doesn't take place all the time. So if you have to collect data, if there is no rain, you can't get the data for rainfall, yes? So you probably need only one topic for this. But just like, if you go to a restaurant, everybody is asking for one type of a dish. You might need 2 chefs working simultaneously to get it processed. So that's the whole idea here, where just like in the restaurant industry, you can have different partitions. So you can have one partition sent here, another partition you're going to send it to this particular node. That means all the reds will go here, all the blues will go here. You can say, okay, these many customers go here, these goes here. That is useful when you're doing SLA. When you're performing if you have a gold customer, you might want to process them first. Yes? Make sense? So even if in cloud, if you have a cloud offering, you want to make sure they are processed faster. So temperature, yeah, in this case, I got 2 partitions here, which are being processed. Now, you don't want to just keep one Kafka broker. You need to have 2 Kafka brokers here. So one Kafka broker here, another Kafka broker here. Now, when I'm sending the request out from here, it's getting processed, and temperature topic is there, and it's getting executed. That means if one goes down, second Kafka broker can still continue on processing. You have to resend the values, but it can still make it happen. So what it means that these are individualized events which are being sent through, and that's what discrete events which are there, which are sent through in this case. So at a high level, it's not that readable, but at a high level you have Akka cluster, which is raw event sourcing which we are sending to Kafka. So if you see here from the data flow perspective, all the blue portions is Kafka. Okay, and Akka is all the white portions are for Akka. And you get it from the user or from the raw data from the database, you send it across to the Kafka, and then it sends it across to Spark, which is the green here, and which sends it to the Cassandra node. And that's really useful, that's what the SMAC stack is. And while combining these two, and that was your question, hey, how does it really perform? It's great for analyzing the large amount of data. And this is for storing data, is really good for storing the data. That's the key part here. And that's where DataStax comes in. We are using DataStax as an enterprise version for ourselves also, and which does provide support for Spark and other things are available here for you to use. You can use this DataStax model to send through the weather channel, all the values from the weather station, either to Spark streaming or directly to Cassandra, depending upon what your use case is in this case. And you can also partition. You can say that, hey, my 25% of the customer will use this Cassandra nodes. So Spark and Cassandra is all in one place. Spark, Cassandra, and Kafka, all in one place. That means if I'm doing raw event sourcing for weather channel for, let's say, India, I'm going to do northern India, southern India, east India, west India. That way you get like 4 of them here, and they're all processed fast. That's the whole idea behind it. So in this case, yes. So in this case, what happened? Transformation is possible if you add these 2 things, Cassandra plus Spark. Yes, you can do transformation, aggregations, and all those things are really possible doing that. And that's where it comes the Mesos. So I know that it's going a little fast here, but I want to give you a full picture, like what's really going on behind the scene here. So in Mesos, what's happening is that Meso has got orchestration tool. It's an orchestration tool, so which is providing a support for Akka, Spark, Cassandra. You can add all these to Mesos, and what it does is, as part of the scheduler, you can add a scheduler to this, and then when you add the scheduler, it can send the request to different agents to process the records. So it's a very good taskmaster, and it's been used by, Apple is using this also because of Siri. It's been processing really fast, doing that. It has a good dashboard, as you can see here. It has a dashboard which has like different services running. Now you can see that CPU allocation is 50%. In this case, memory. What's the memory allocation, and different ways to look at this. And you can install different versions of products also. So let me just show you 1 second. Go to the right place. So it will be there in my slides also, so you guys can do it when you go home. But the whole idea is that you can actually launch a cluster. So the launching a cluster is pretty easy. You just say launch sh. And what it's doing is it's starting the DCUS, which is running in the background. And it takes like few seconds to run. And basically once it does, then you get DCUS running in the background, which you can use. So any questions so far on this one? Yeah. So it's just taking a few seconds to load. Let me go back to the slides for a second. So what you can do is you can actually download different versions. You can have Apache Spark. All these you can download and start using it right away. You can also have something called resource offers, like you can say that, hey, for this particular resource, I want this much memory space. You can control at a particular IP address itself. What all are the roles which are given to each IP? You can control that in this case. Okay, let's see. Let me check if it's back here again. All right. So let me talk about this, and then we can go back to that one. So what we are trying to do is that it's actually providing us a platform by which what you can do is you can have a different softwares here, like you can have different jobs running, scheduling jobs which are there. As part of the platform, it's providing us logging and metrics, which is the orchestration tool. It has to provide us, like we talked about it just before this one. It's providing us all these facilities, which are on the left hand side for us to really use in this case. So let me go back again. Okay, all right, it's back. So let's see here. Okay, so now I already have the DCUS set config for the CLI. Now what I can do is I can actually go and look at my dashboard. So let me just copy this and let's take a look at the dashboard first of all. Okay. So it's coming up right now. So it's saying that it's 0% available, CPU utilization, memory utilization, there is nothing here for us. So this is giving us a DCUS dashboard. And now what you can do is, within this particular dashboard, I can go to the universe. They call it universe. I can go here. And I can install a package. I can say, okay, I want to install Kafka. Okay. And then I want to install Cassandra. So which is pretty easy. I mean, so what's really happening is they took care of the pain points which we all have of like actually configuring, a system which runs all of these at the same time. So what I'm trying to do now is I'm installing all these, and then Marathon will be part of it itself. So you would not need to do that, especially for this case. But it's not only this. I mean, everyone has provided support for this. Kornos and others are available, and you can get any of these. So Kafka is also there. You can install this. Now what's really happening is that now I've installed all these products. If I need to see what products are really available for me to use, so if I can go to services, and let's go back here for a second. There is another thing called Marathon. So Marathon provides me a support where I can see actually, I just added, different applications just now. I added, 4 applications. So all 4 applications are added. They're all waiting for me to send a request out to them. So what else you can do is you can actually find out DCUS node. There is one node for DCUS which is running right now here, and in this particular case, and which will give you, these are all the different options which are available. So Marathon is a way of managing your applications in DCUS. You can add this to basically add different application from the CLI perspective. Now you may ask me like, hey, we did not add any service yet. Yes, so that's the next thing we're going to do. So what we're going to do is we're going to look at a CLI way of launching a particular application. So in this case, I'm going to launch an application through a CLI mode where I got this instances. So what I'm saying is that this is a web server instance which I have got, which has got public slave. It's getting this image. So now where is it going right now? Can anybody tell me? Where is this going? This is going to the Docker Hub, getting this image from there, and what it's saying is that I want only one instance running right now. So instead of one instance, you can put 4 instances here. If you say 4 instances, it will be the job of DCUS. If that instance goes down, it'll add another instance right away. That's the beauty about adding it this way.
How is that any different from whatever we discussed the previous session, Kubernetes?
So Kubernetes, so what you can do is you can also put Kubernetes along with this. So you can still use DCUS, but you can have Kubernetes on top of it. So DCUS will manage all other applications which are running. Like, Cassandra is running, right off the bat, you're going to get that. Spark, you're going to get that. Other things, you're going to get that. So it's like smack stack, but with Kubernetes. I mean, that would be my ideal choice. I mean, if I need to design my system currently, that is a good way of because orchestration-wise, design principle-wise, it really provides, Kubernetes provides a good framework where you have services which are bounded, you're not calling another service till the time you expose it. It provides us scalability. All those aspects are really good as part of a design language. So that you can get from Kubernetes. But if you put that along with this stack, so you're going to have Smack stack with Kubernetes. I mean, that would be an ideal solution. And I think I did talk to Ken last night, actually. We were discussing about this. And he said that they're committed. So I hold up to him, like, because he's also one of the committers for this one. So I'm also looking forward to trying it out, because I had the similar problem that, hey, how am I going to use with Kubernetes? So they're saying they're going to support it. That's a good question, by the way. So now you have one instance running. So what you can do is you can add, what you're doing is DCUS marathon. You're saying DCUS marathon app add. So when you did DCUS marathon app, so I just added an application. So when I added that particular application, and I can actually list that application, it's going to show me exactly what the Docker image is. It shows me Cassandra is there, Kafka is there. So when I say list apps, how many apps are there? Cassandra, Kafka, and other applications are there. I can also go to Marathon. And when I go to Marathon, you see this here? I just added one more application here. So this application is running right now, is one application which is running in Marathon. I can go and find out and actually scale that particular application. I can say, hey, instead of one, add 3 nodes. Scale the application. Now what will happen? It will automatically, running one instance. See this? It's now one. It's deploying the other 2 instances really fast. And basically adding it to the network, and then we should be able to see that coming. So if I go here, you're going to see that memory allocation. It's 4% right now, but once the other 2 are coming in, then you're going to have more allocated spaces in this one. Okay? And then you can curl. So when I do a curl here, this request is processed by whatever the deployment which we just did. But instead of this, if I go back to Marathon, it's still deploying it right now. It's still in the process. Once it finishes, it will be processed by then 3 of them. It will process one at a time, and it will send the request from there. So you can also view the cluster. Now if I can go DCUS dashboard, if I want to see this, how does it look like? So this is the DCUS dashboard. And if I go to this one, what are the services running? So it's showing what's the health of there was one question asked, like, how do I find the health? So there's only one service running right now, which is Marathon. But you can add other services if you want to add here, which will be running. And it's saying it's healthy. So, and you can go to that host name. It'll tell you, what's the usage, what's the disk space it's using. Now it's increasing right now. So, see this increasing here? Why is it increasing? Tell me. Anyone? Because I just scaled it. So let's check it out. Now I'm going to go back to here, to Marathon. Yeah, so it's still processing that. But you got the idea what I'm trying to do here. You can do the exact same thing through UI also. You don't have to just do it through here. So if I go to Marathon here, what I can do is I can go back to applications. So I can add another application. I can add my own application. I'm going to call it like WS, for example. And with that particular application, what it's doing behind the scene, it's creating the same JSON object. You see this? So it's behind the scene, it's actually doing the same JSON object. Now what I can do is, same way as I created the previous one, I'm going to say that, hey, I want to add this as my image. So this is the image being added. And now if I go back to JSON object, it added that image. So you got the idea. Okay, I wouldn't want to go there, but you got an idea like what's really going on with this. So it's pretty easy to build through UI also. I like the UI too, but you can do the same thing through command line, CLI interface, which is pretty good also. There is a playground here also. I'm going to put it in my slides. You guys can use the playground to try it out. So we talked a lot of good things here, as a Smack stack as a whole. you see that we started with overview. We looked at SMAC as a whole, like, starting like, Spark, how these are processed. What the big data characteristics is, how the NoSQL fits in, how the Spark streaming takes place, and then we looked at Kafka and Akka, and later on we did the cluster management. So it's like 1 hour for all these technologies, guys, like it's an overview, but I'll have step-by-step action item you can actually do while you go home through my slides, which you can go through and understand what's going on. So any questions? Any questions? So you guys are really good in asking questions. So that's really really nice for that. All right, thank you guys, and you have a great time. Enjoy the last day tomorrow.